So, this is a super long title, isn't it? I almost was seeing how much I could fill that box there. Anyway, as you might imagine, it's all about HTML5 on the phone. Kind of doing the mobile web, and I'll touch a little bit on the hybrid web apps as well here at the end. I'm going to just get some demo stuff going here. To get started. All right. So, did anybody try to come to this session before? A couple days ago? Yeah. Did anybody stay and watch the video? Wow, I'm impressed. It was probably weird and strange and eerie. Yeah, I promise to be awake for this session. I really will. Yeah, that was kind of crazy. So, let's get after it. Probably done this ad nauseum. I actually do, so in this bottom thing, the Jumpstart for Windows Phone 8, I actually do a session in that that's kind of like this one that talks about doing some HTML5 stuff and talks about capabilities. But no doubt, most of the Jumpstart videos are around building native apps and things like that. So our takeaways, really simple. Learn best practices for the mobile web, and then we're going to see how you can leverage HTML5 capabilities that are in IE10 to build web apps. I started doing a session on mobile web several years ago, and it was probably the only reason I did it is I felt like I was the only guy at Microsoft who would do a mobile web session because everyone else is doing apps, right? And so the mobile web wasn't very sexy or anything like that. And when I started doing mobile web sessions, the whole session was best practices, and it was really nothing as exciting as what you get in HTML5, but it was to reach as many devices as possible. Because as we go backwards in time, you had more and more people with feature phones, right? That didn't always have, a browser like you would have with a smartphone. And so the ability, and so over time, my best practices slides would get shorter and shorter, and I would talk more and more about HTML5. So, but I didn't want to get rid of best practices because while it's exciting to know about all the new HTML5 features that are supported, there are some other things at work that are going to help your mobile web apps be successful that have absolutely nothing to do with HTML5. This is an interesting little tidbit of information from Gartner, the analysts who do all the reports that the CIOs buy. So this is not me. So whether you're in love with building apps or if you love building the web, this is kind of the trends they're seeing. They go out and do surveys of big companies to kind of see where they're headed. Sometimes you have people who are just guessing, and I know you have lots of people on the internet making predictions. But a lot of this is actually coming from surveys from management executives and companies. That's a big shift. I mean, right now we're in the middle of app land. It's hype, the heyday of apps. But there's a reason why the pendulum is starting to swing back towards the web, especially in the enterprise. A lot of it has to do with getting products out faster, targeting multiple devices, and sometimes good enough is good enough. Oh, and if you've been to our sessions, you've seen this over and over again. Big takeaway, we've got Windows running on every single platform now. It's the same kernel, same core everywhere, which makes it easier and simpler for choice. Obviously, we have Office and Link and Skype and all of our products running in every different form factor on every platform. And of course, we make it easy for you to reuse your code and target multiple devices from Microsoft now, since we all have the same underlying platform, same underlying WinRT runtime.net. And of course, as we're going to talk about more here, the same thin client. We have the same version of IE running on both. And then great management story for managing your laptops, desktops, PCs, iPhones, Android, whatever you got. So what I'm going to do here is I'm going to focus on user experience best practices. Are some of you getting blinded by this light? I keep seeing people look up and it's glaring. Is it shining right on you? I don't know if we can do anything about that or not. Do we have a light switch in the back? Oh, well. We'll just move along. All right, I'm going to talk to you about just talk about some things around the mobile web. This is what the mobile web is and should be, actually. You can obviously disagree with me, but on the left-hand side, if you go to a lot of mobile web sites, news sites, just information things, most of the time they're kind of like this. They're single column, lightweight, just text mostly, maybe a few pictures, and it just scrolls vertically, not horizontally. This is what the mobile web is not. Now, back when the iPhone came out, that was a big deal. They used the WebKit browser to be able to render a full-size website, like the New York Times or the Wall Street Journal or the Financial Times or whatever. And we used pinch and zoom and all kinds of things in order for you to zoom in and see what was going on there. It doesn't mean that was a good user experience. You could say it was a workaround, or you could say it was a hack, because this is not a good user experience. But in the early days of the mobile web, we didn't have people building sites that were targeting devices right away, and so we had to find a way to read these big websites. But we know this is bad just because it's too much information. And what's a browser? What's a web browser? It's just a text parser, right? And so if it's having to parse all that extra text and the styles and everything, it's going to take longer, it's going to eat more CPU, eat more battery life, things like that, versus a lightweight, small, mobile web optimized website. So what I'm going to do is just I think it's the next 4 slides, kind of rapid fire, I'm just going to go through a list of best practices, and I'll show it to you, and then I'll just kind of give you a little commentary about each one. So top-align form fields. So this is like when you're building a web app and you've got forms, text boxes, things like that. Some of these are real simple, some you already know. When you're having form fields, make sure that the label for that form field, like if it's a text box to enter in your first name or last name. Is that me? Anyway, make sure the labels are on top of the text boxes. Don't put them to the left of them or the right of them. Make sure they're all stacked on top of each other, going like that. Because you need to assume a device that's just going to be narrow and a single column. Separate your CSS and JavaScripts from the HTML. Now, I know this is already a good practice for a long time for a variety of reasons, but it actually has validity in the lightweight, fast mobile web. And the key reason that you don't want to have it built inside the body of the HTML text is because you're going to have to all right. Oh, I'm feeling better already. Excellent. Oh. So keeping these separate. The big takeaway here is if you're always putting CSS styles and always putting your script in each web page, you're downloading more each time. Instead, if you have them separate, yes, that first page that comes down is going to pull down these separate files, but then the subsequent web pages that you go to, they're just going to reuse these files because the web browser is going to cache these locally. And so over the life of your whole site, it's much less to download. Minimize need for text input. This applies to apps as well as lots of typing everywhere. That cool new keyboard that you saw this morning in the keynote with 8.1 where you can slide along and get help. It's all good. All right, so the next thing, use the 20% most important content from the desktop. What that means, I talk to lots of customers and they have their giant website for the desktop and it has a million things on there and they say, I want you to take that whole thing and put it on the mobile device website. And it's just crazy and it doesn't make sense all the time. Maybe one day it will. But right now, find the most important things from the big giant website to put on the mobile website. So, good examples, if you like airlines, you may not necessarily make an airline reservation on the mobile web version of, British Airways or whatever. But you want to just do quick glance and go type things. I just need to check and see if my plane's on time, just little things like that. So always, when you have customers that are asking you to do that, you really should push back on them and tell them that, well, don't tell them they're crazy because they may not pay you, but you know what I mean. All right, minify. Do you know what minification means? If you're a web person, you probably do, yeah. So anyway, all that white space. So when we're building native apps, right, and you're writing native code, whatever language, all that white space around there, it doesn't matter because you compile it down and it doesn't make any difference. But white space on a web page or a JavaScript file or CSS, it actually uses space. And it makes the file bigger, even though you don't see anything. So I remember the first time I would, I'm always trying to make beautiful looking web pages and indenting your tags and everything looks nice. And I remember the first time I did the right click on the browser to view source on one of a Google website or the Gmail or something like that. And you know what I saw? I saw the ugliest thing I'd ever seen before. All the text was all bunched together and wrapped and it was ugly and I didn't know what anything meant. And I'm like, oh, this is horrible. Well, I didn't know what I was talking about, obviously. The beautiful page that looked pretty, that was horrible. It was taking up too much space. The Google guys knew how to minify their pages and tie it all together. And so when you use these minification tools, we have some now in Visual Studio, and there's lots of great ones you can get on the internet. It compresses all that white space. So you might save 30% in size. This is all part of your user experience. We want that page to load fast. Transcoders. This is a crazy one. So if we go back in time, let's go to the late 90s, early 2000s, we started having more powerful feature phones that had web browsers. And first they did HTML and WAP and things like that. I don't know if anybody remembers those. And then they started trying to render real full-size web pages. And what they did is, in order for you to see a big web page, they decided in their infinite wisdom, this is all the mobile operators around the world, they put in these hardware transcoders all over the internet where you would go in and out of a mobile operator and then onto the internet. And so when you would go to maybe a big website, like the New York Times or whatever, for instance, it would go through this transcoder and chop it all up and give you what they thought you would see in this little low-resolution text browser. Well, a lot of those transcoders are still out there on the internet today. And when you're building a mobile website that's optimized for mobile and not a big thing, there is still a possibility, not always, but there's a possibility that one of these transcoders will try to modify the way your mobile website looks like. And obviously you don't want to do that because you've spent a lot of time and effort. So one of the tags you can put in the header, you can push this out, in a cache control like on ASP.NET or something like that. It's just this no transform is the value you want to pass to it. And that tells the transcoders to leave your page alone. It's insidious, isn't it? All right, link to the JavaScript. So we have separate JavaScript. Normally you link to it up in the head. Why not link to it at the bottom right before the closing body tag? Not in every situation, but in most situations. And why is that? All right, how fast the page comes up or your perception of speed. Remember in native apps, we started doing things like having background threads to load lots of stuff so the page would come up faster, the screen would come up faster in native. Well, you need to do a lot of things to help the perception of your speed of your page with users as well on the web. So, because remember, a browser is just a text parser and it's going from top to bottom. It's like chugga, 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 going down, gets to the head, sees JavaScript, shoots out here, parses and loads JavaScript, shoots, So what you can do, unless you need an onload event to fire, if you don't though, it doesn't hurt to put the link to the JavaScript tag at the bottom of the page. And so the reality is what happens is the page loads super fast and the user sees the page quickly and then it silently, quietly loads the JavaScript in the background. It's just a perception thing, but to get it to load faster. Each page having a single function or idea. This applies to native apps as well for devices. What I mean by that, if you'll remember back in let's think back to the 90s. We're building client-server apps and VB or whatever, connecting to big databases and stuff like that. And everybody tried to cram as many controls as possible on the screen, and it looked like mission control or something like that, but you thought that was the right thing to do. You had it do everything. Well, it's not a good user experience on small devices. And so you need to actually do the opposite of that and actually waste space by making sure each single page stays lightweight and it's only about one thing, not about 30 different things. Just one concept. Keep it simple. Turn on your server compression on your web server. IIS, has the gzip and deflate thing, checkboxes. I think static is checked by default, and you can check the other box in IIS for dynamic. It makes a difference if you can start compressing all those images and things. Now, here's an interesting statistic that you should think about. 74% of people will leave a mobile website if it doesn't load in 5 seconds. That sounds pretty demanding, doesn't it? But these are stats that have been coming back over the last few years. And a lot of it, a lot of times you'll see a lot of mobile websites for retail companies and things like that where people are shopping and comparison shopping. So this kind of goes back to a lot of my other best practices about keeping things light and small, is it needs to load fast. You might have heard, I think in the last year, the W3C came out and said that the average web page is now 1 megabyte in size, which is a horrific thought that we've made the bigger, fatter, bloated web pages. Obviously, you don't have the luxury of doing that on the mobile web. It needs to load super fast. And so kind of going along with the first one, every extra second increase in load time, you see a decrease in getting sales and people being happy about it. And a lot of people are just leaving. So this is a pretty provocative statement, keeping your pages under 20K. That probably sounds impossible to you, but it's not impossible. Use this as a goal to shoot for. I know you won't be able to hit it all the time, but think of this as a goal to shoot for. When you're thinking about building your mobile websites, don't think about the fancy, exotic websites. Think about the Google homepage. Let that be your guide as what your mobile website should be like, and always be checking the size to keep it light. Use larger fonts. This is counterintuitive, kind of. It goes back. I remember when people started building mobile apps, and like 10 years ago or so with the Palm Pilot and then the Pocket PC, and they were trying to do like they did on the desktop. They made the buttons smaller, the text smaller, so they could fit more on, because they said, I don't have any space, so I got to do this. You need to do the opposite. Waste space. Make the fonts bigger. Just like you see with our Metro typography, is really big. So big fonts that you can see, and then big UI elements, because we're doing touch. We used to use the stylus, which is a nice precision pointing instrument, but now we have big fat fingers. So you need to design for a possible 80 pixel size finger. So that goes right along with the big fonts, big buttons, big list views, big everything. Again, keep each page very simple so that you can use bigger things. The next two here are about capability detection. This Wurfel database is out there, and you can tie into it, whether you're using PHP or ASP.NET and others. And it has, I don't know if it's in the millions or not, it's certainly in the hundreds of thousands, I think. Basically, every phone that's ever been created and every browser for every phone is in this database. And it's a server-side deal, and it can detect the phone coming into your site, and it can tell your web app what features it supports and what it doesn't, so that you can appropriately display what they need. On the client side, you can do the same thing. Lots of people would mindlessly, very often, it's not a big deal, look at the header, it's Mozilla 1 point whatever, and they would basically try to say, I know what browser this is, and so I automatically know what capabilities it has. But sometimes it trips you up, and you're not right about that. So another thing to do, part of defensive programming, is use JavaScript. You always check to see if a function exists in JavaScript before calling it. If ... then do it. Instead of just assuming, it's IE6, so I know it's going to do this. Don't do that. Let JavaScript, so be defensive in your program, and you'll see that in some of the code I'm going to show you. Here's another crazy one that most people don't think about. Having lots of linked resources coming from other places, whether it's actually links, pictures, images. Yahoo spent a lot of time trying to do super optimization, and they found that what was killing their performance was DNS lookups were slow. Because as the page is loading, if pictures and things were coming from different places, it was having to do a separate DNS lookup every time. All this stuff takes time. So this is a mobile thing. There's a thing called a viewport tag that you can use. And basically what it does is you set the size, what you expect the size of the browser size to be, and it's just perfect for optimizing and making the website kind of look like that first picture I showed you, to optimize for mobile devices. Because not having the meta tag, your mobile browser may think, oh, I might be about to look at a big giant website, so I'm going to render it this way. Having the meta tag will prevent that from happening. So speaking of UX and the way things look, let's talk. Does anybody know about responsive design? All right. I'm not for or against it, because I know for a long time, a lot of people are like, oh, responsive design is going to be great. But I know just as many people who think it's a bad idea. It's kind of interesting that we'd have a debate like that, because for a long time, you've been going to a site, and if it detected it was a mobile device, it would go to maybe a different one, m.whatever.com, and then the other way it would go to mobile. And now we're thinking responsive design, we're going to have one website for everything. It sounds like a great idea, but you have to be aware of some shortcomings. So basically, the gist of this with responsive design is styling with CSS so that the property, the right page is shown depending on what browser you get. And so the kind of common thinking, if you have a wider website on the desktop with multiple columns, and then maybe when you shrink it down, it's only got 2, and you shrink it down to a device and it only has 1. So that's the idea around responsive design. The problem is, all browsers and everything are not created equal. And so what I see happen in the real world is the entire website, all the assets, everything for the full-size website are still downloaded to the mobile device. Even though it's rendered its size to a single column like you want it to, it's pulling down too much data. Now, there's ways to get around that, but for the most part, most people are doing it, and so it doesn't. You missed out on the value of having a targeted mobile site. Because remember, we want that 20K site if we can. And sometimes responsive design will end up getting the big 1 meg site that looks like a 20K site, but the user's still waiting for a minute, and they've already left. Here's just a quick view. It's not exact in the code, but in CSS that you would have, how media queries work, the big takeaway here is, right at the top, the media screen, the max width, 480 pixels, and then inside that, those curly braces, that's where you'll put how you want that to render and how you want it to look at that width. But then it can also detect if it's, maybe it's 650 pixels wide, and so on. You can do this more and more. That's the basics of how you'll do responsive design with media queries. Let me just show you a couple quick websites here. Just to give you the idea of how media queries work, or how they look in the real world. And you may have seen this before. We have our test drive site. So this is kind of the view, the full-size view on the desktop on my laptop of this particular site. And so it's using responsive design and media queries to render it this way at full size. But then, I'll kind of drag it from over here. As I shrink it down, you see the images shrinking. Sometimes they are substituted with smaller images, actually, if they do it a good job. And then you see the boxes around them are shrinking and changing in size. And as I get smaller and smaller, pretty soon, now I'm not seeing the pictures. I really wasn't supposed to do that. Maybe I lost my internet. I did lose my internet connection. Well, that's always just a plus, isn't it? That's really helpful when you're doing a web demo and your internet connection just doesn't work anymore. Excellent. I'm feeling the love now. All right. Anyway, you get the gist of it. Anyway, that's how you get down to a mobile site and everything. So that's the idea behind that. And I'm going to hope that I'm going to connect to ShowNet real quick. And hopefully that'll work for us. Of course I can't connect. All right. Well, we're not going to break all the rules of being a good presenter by sitting here and trying to figure things out. So let's move along. All right, so let's get into HTML5. There's a lot to HTML5 and a lot to CSS3, ECMAScript 5, things like that. What I'm going to focus on are the things that you would use in real apps. There are lots of other HTML5 sessions where they talk about doing 2D transforms and lots of cool, pretty things with CSS. I have no idea how to do that stuff. I'm not an artist. But these are the kind of things that you would use in a real app. So basically, this is just a table that lists
and pretty much every device supports all of these now, except for Safari, as far as IndexedDB. But going down the left-hand side, things like web storage, geolocation for for GPS, the canvas tag, audio, video, the new version of the XML HTTP request for doing AJAX calls to web services. There's a new forms thing, so you get a lot more cool UI look and feel in the forms. Things that you used to think of as a custom control are now just built in, like slider controls, and lots of great things are part of the spec. It's great. App cache allows your site to stay offline. Web sockets, it's exactly what it sounds like. It's negotiating from HTTP up to a socket connection, so high speed and push. Web workers is threading for the web, and IndexedDB is the new W3C database that replaced, there was a web SQL for a while, but they deprecated it. So IndexedDB, it's kind of like NoSQL. So IE10, hardware accelerated video, HTML, Canvas, all that stuff is all hardware accelerated. The rendering of all that stuff is hardware accelerated. And we ensure we have GPUs in every device to make sure that happens. And so instead of the typical parsing that you get, it's all hardware accelerated. Then we also take the JavaScript and we have a JIT compiler for it. And IE10 is the first version where we've had the JIT compiler on the device. So the device will be able to, the gist of it is when you're building JavaScript intensive web apps, you'll see a huge performance boost. So when you put the two of those together, plus following all those web best practices I showed you before, you're kind of getting the idea of how you're going to have a great user experience, even before we talk about things like HTML5 stuff. Smart screen blocks websites where objectionable malware, things like that might get download or drive-by attacks happen. We have a sandbox. This is a different kind of sandbox. I know a lot of times I talk about the browser itself is in a sandbox and protects the rest of the device, but this is actually a sandbox as an HTML5 thing as well. It has to do with when you're using iframes and having other sites be visible with this other site. There used to be a security hole in that, and so this takes care of that problem. DataSense, if you've been by the booth, I've talked about DataSense. It's our compression servers that we have with the different mobile operators that we're rolling out. And that will give you 45 to 50% compression for everything. So whether it's the web or your apps or email, sending email, you're gonna save a lot of space because of the DataSense compression. So let's just dive into each of these features and talk about it. So geolocation, as you might aware, it's making your mobile web apps location aware. Just like you see lots of native apps that have maybe mapping controls and things like that, and you use for navigation, you can do the same thing for the web. So this is JavaScript API. It is very simple to work with. In fact, what I found funny is the code for it looks actually very similar to the C# code that we use, like if I'm building a Phone 8 app, actually. So as you might imagine, GPS is the most accurate by far, and there's two levels of GPS. You can do a more accurate version, but it does drain your battery. And of course, it doesn't work indoors because you can't see the satellite. Then you've got lots of databases out there around the world that store IP addresses and Wi-Fi access points to help you find your location, triangulation that way. As you start to see more, you probably read, Google and some others, we're doing some work on indoor navigation, like if you're in a shopping mall and finding things that way. A lot of that will come from things like Wi-Fi access points and figuring out what you're close to. And then last but not least, cell tower triangulation, which is, vaguely accurate. So in addition to just finding it one time, you can also write geolocation code that can track your movements. And so what that's actually like is like a real navigation system where you see yourself moving and the roads going and that kind of thing. And so it's really simple to build. It's only a little bit more code than just finding the one time lat long. And then you can measure coordinates. You can take two coordinates, like where you are and something else, and I've got a formula I'll show you. You can have the code for this. That'll tell you the distance between these two places. So now if you put it all together, you can imagine using a mapping service. I'm sure it'll be Bing, right? And you can build that whole navigation thing, you knowing where you are and knowing where you want to go and how far you have to go, and then you can calculate time. So pretty powerful. And the other thing is we don't want Big Brother looking in to find out where you are. And so just like in native apps, using this always prompts the user for permission in order to do this. So here's what I'm going to do with all these examples. I've decided to put the code as big as I can in these slides, so that, because you'll get the slide deck and it'll be an easier way to make sure you have all the code and you can just copy and paste it. Because I have so much content to go through, it would take a long time to do demos for every single thing in code, so I just put all the code here. So let's just take a look at this really quick. So there's my defensive programming at the top, if navigator.geolocation. That's my JavaScript testing to see if it exists. If it doesn't exist, then it's not going to work and we're okay. But if the browser supports it, then it'll just do get current position. And so this is as simple as it gets. And then I just kind of pass along to this function here, this display location. I pass the position that I get back from the callback, and I get the latitude and longitude. And so you can use that and you can put it onto a map and see where you are at that moment. If you want it to stay on and keep tracking movements over time as you're moving instead of a one-time thing, it's just a little bit different, but it's pretty close to the same. You just create this variable watch ID, and you might have buttons like start and stop, something like that on the web page. And you do the same thing. You test for geolocation, and then you do this watch position, and then it returns to this watch ID, and then you call that other function I showed you on the previous page. And basically, it'll just keep going. As you make a significant enough movement with GPS or whatever, it'll update your position. And then here's the formula for computing distance, which that's a lot to take in. But anyway, you can copy and paste it into your code if you want to use it. All right, let's talk about web storage. So, got to take data offline so that we can do things just like a native app. So it's a browser database. This initially was thought of as a replacement for cookies. So there's a couple of versions of this. There's local storage, so it's 5 mega data, and it's this like name value pair type thing that you do. So it's not a relational database or anything. And then the data will stay there until you overtly clear it. But if you don't, you can close the browser, it'll still be there. You can reboot the device, it'll still be there. Now there's a different one called session storage. This one only lives as long as the browser is alive, or a tab on the browser is alive. And as soon as you close the browser or close the tab, it clears this. Let me just think about this too. You may, for certain, like if you were building a banking app or something with sensitive financial data, you may want to use session storage because you really want to clear that local data out as soon as the user is done with that, rather than keep it around if it's sensitive information. And then so this, again, you might use cookies for some state stuff or things like that, or your session, but it can only hold 4K, and this holds 5 meg, and you're not sending cookies round trip every time. So let's take a look and see what this looks like. It's really, really simple. It almost looks just like how you set cookies and get information from cookies. So up at the top there, you see the insert, and I show you 3 different ways to insert an item. So it's just a key and a value, and they're typically both strings, even though you can parse it out into integers. So you just have a key, whatever you want to call it, and then you pass in a val. And so you can do the set item. The second one shows you how to do an integer, or you can do, the third one here shows an indexer as far as setting that equal to a value. And then it's real simple, as you can see on the bottom, how to get that data back out again. You have your variable, and you just say get item by string, and it gets you the value. If you need to get the integer out, then you use this parse int function around it to make sure that you get the integer version. Because you know how the internet is. Everything's really a string, right? And then here's the way to do it as an indexer. So pretty simple. Oh, but there's more. We can do arrays in web storage. So we can go beyond simple strings and primitives and put a full array. So here I created a car array, and I have 3 different cars in my array. And then I use this wonderful thing. It's one of my favorite features of JavaScript, is this JSON.stringify and JSON.parse. So JSON.stringify can just take just about anything and turn it into a JSON string representation of that. So this is great. So now I'm just going to say car array is my name, and I stringify that array, and it does it for me. And then when it's time to get that array back out to use in my app, then I just do the parse. So it's pretty clever that you can actually do an array as well as primitives. But you can do more. You can do objects. just like we do in real programming, right? Objects. Okay, JavaScript objects are kind of strange, but you know. So here I've got a car object with a make and a color, and then I can new up that object and make it a black Mercedes, and then I can use the same JSON stringify and put that black Mercedes into the database, and then I can pull it back out, and it's an object again that I can use in my app. But I can go even crazier, and I can do an array of objects. And so I have my black Mercedes object up here, and then maybe I have multiple cars with multiple colors or things like that. And so I take those arrays, and I put each array, each object into an array, but I can still use the simple JSON stringify against this car array, and it'll have an array of objects in there. So pretty powerful stuff, actually. A lot of things that you might want to do are completely possible here. So let's talk about web services. That data's got to come from somewhere, right? That data we're going to put in web storage. So Microsoft invented Ajax. We just didn't know it a long time ago, 10 years ago, when we had our ActiveX type stuff. So XML HTTP requests, there's a new one, it's called Level 2, it's part of the W3C standard, and it's how you're going to make calls, Ajax calls, to call web services directly from your page, not having to submit a page or anything like that, but keeping state. Your page is not submitting, it's just calling directly. This Level 2 thing allows, the big thing that people notice is it can do cross-domain requests. And you do some configuration, because typically in the past you could only call back to the exact place that your website's coming from. So this gives more flexibility. And then it has these cool progress events they can fire. So you can imagine now having a progress bar in a web app, which is amazing, and do file uploads. So it's pretty powerful. Now when we combine this with what I told you before, we have a JIT-compiled JavaScript engine. That means these web services, the calls are going to be much faster because it's going to be compiled with our JIT compiler. So you're going to see a more responsive callback. The native thing that the web and JavaScript understands is just REST services that returns JSON objects because it's built into JavaScript. So it's lighter weight. REST and JSON are, REST is much lighter than SOAP. JSON's much lighter than XML. And so that's what you want. That gets you that best user experience. So we're using less bandwidth. Remember, we're a text parser. So we're parsing less text when we're using REST and JSON than if we use SOAP and XML. And then everything moves faster. So here's how a simple Ajax call looks. Just varring up a XML HTTP request, opening, pointing to where you want to call. It could be that's a CS/HTML. It could be a REST service. It could be WCF, Web API, things like that. And it's asynchronous. And then the onload function will fire when the value data comes back. And if it's request 200, then that response text, that request, that's your answer. You get it back. One thing I'll mention right now, everything I'm showing you is the actual code to really do JavaScript. And I know that might sound like a strange thing to say, but everywhere I look these days, when I'm looking at HTML5 and JavaScript books, without even saying it, they're showing me jQuery syntax for everything now. And it's assumed almost that I'm going to be using jQuery. And jQuery Mobile are great tools to help speed up your development. But I was a little worried that people are going to forget how to actually do the real thing. So I don't have anything against using jQuery, but I'm going to show you how the real code works. So now, here's a scenario where I get to put that Ajax call together with the web storage I just showed you. So you're probably wondering, why do I care about arrays of objects? Well, now it kind of makes sense. If I'm calling a web service and it's returning data from a database table, rows and columns, and those are serialized as JSON objects, when I retrieve that, like here, that response data, I can immediately put that, because remember we talked about how JSON's just a first class, we had that JSON stringify and everything. So I can just get that Ajax request, and I can immediately put that whole thing right into the database, right into the web storage. And then when I want to get it out, I just do the JSON.parse, and I have that whole collection of objects, because I can do object arrays in JavaScript. And then here at the bottom is just me doing a for loop to iterate through what was in there, and you can kind of, I'm just doing a document.write, but you can imagine filling a grid control or things like that, a table. And it works with object notation, so it knows that, what I pulled back from the AJAX call was a product and a price, and if it had a floating point, I can use parse float. So pretty cool stuff, pretty powerful stuff here. So app cache. This is another W3C feature, and it basically lets you specify a manifest file that allows you to tell certain web pages, JavaScript files, CSS, images, to work offline. And so this is a remarkable feature, and this also goes towards making these web apps more app-like. So you get offline browsing. It'll pre-download those pages. Again, in the past, we built native apps because we knew we didn't always have a network connection. Well, with this, I can have my website be offline. I could lose my network connection, and my website will keep working in an offline mode using app cache. It also helps scalability of web servers, too, which is really interesting, because it intelligently detects if you're up to date with the latest pages. And so instead of every browser on every device always hitting the web server to get new things, it just does most likely it's going to get it locally from the cache. And then it has this intelligent way to just test really quickly to see if what it has is newer than what may be updated on the web server. And so because of that, you'll have less load on your web servers, which means you can serve more people, so you can scale. So simple text file, I'll show you here in a second. It's just this manifest file, and it just lists pages and style sheets in JavaScript, and also allows you to specify things if in case the web server can't be reached. So here it is. It's really this simple. It's just a text file that you put inside with your website, this cache manifest size. So in that cache area, that just defines the pages and JavaScript and CSS and images that you want to download and have be offline so that you can keep working offline. There's the fallback section. In case something goes wrong, it can fall back to a different page. It's kind of like some kind of, think about it as network error handling a little bit. And then at the very bottom in this network area, if there's a pages or things you absolutely never want to be cached, you list them there. It's really that simple. So what goes good with this is IndexedDB. So this is a relatively new thing. It's getting mature now. If you need more storage than what you had with the web storage I was showing you before, like larger amounts of data, 5 meg is not enough, and you need 50 or 100 or whatever, and be able to ask permission to get bigger, IndexedDB is what you want to use. So it has these object stores. You think of each object store as a table. Now again, it's not relational, and it's kind of similar to web storage. It's kind of like if you've ever worked with a NoSQL database, like CouchDB or MongoDB, or if you've worked with Azure Table Storage, think of it like that. The one cool thing, though, is that you can create indexes on these. And so even though it can have a lot of data, and even though it looks similar to name value type stuff, it's indexable, and it also has the ability to do kind of what we in SQL Server land would call an identity column. So pretty neat stuff there. The other thing is every operation is asynchronous, and every operation you do is transactional. It never lets you just do an operation, an insert, an update, do changes, things like that. Everything is always wrapped in a transaction, which makes a lot of sense. And actually, it almost makes me think that they were thinking about mobile devices when they built it, and not just a desktop web browser. Because devices can fail for a lot of reasons. You could have network problems, batteries run out. I mean, I've used mobile devices forever, and I can think of a million ways why they go bad. And so this helps you keep that durability, that almost like that ACID support we think about with a transactional database. This is going to make sure that you don't have corrupted data or things if something goes wrong or if the browser dies or something like that. So here's how this is just some simple code of how you create IndexedDB. And so you just do the window indexedb.open, and that kind of creates the database. And then you'll kind of notice here, everything's asynchronous. So you wait for this onSuccess event to fire, and then you can actually version multiple versions of the same database or table, if you really want to think of it, and then catch errors and things like that. And so we have some great in-depth information on this on MSDN. If you are building, I don't know if anybody's building Windows Store apps using JavaScript and HTML, like the WinJS stuff, this will be your database for that as well, for your apps using WinJS for Windows 8, Windows Store apps. So let's talk about web workers. We're just getting more app-like by the minute, aren't we? So web workers. The web has always been a single-threaded operation. The main UI thread is where everything runs, and so if you do intensive tasks, it can seem to freeze for users, and they won't know what's going on. So a web worker allows you to spawn background threads that run in parallel. So just like we do with native apps, we use multi-threading to be more responsive and get more work done in a lot of different places. So what you do is that, remember we got our separate JavaScript files? You basically you write particular JavaScript files, and inside that JS file, it has a function, has the work that it's going to perform when you create a web worker. So the web worker, you'll point to the JS file, and it'll fire it up, and it'll start doing its work. And the browser will allow up to 25 web worker threads, which is great. It's great. I mean, we're going from only one thread to we can use as many as 25. This is pretty powerful stuff. And this is how simple it is. var worker, new web worker, point to this particular JavaScript file that's doing some work for you. And then here's how you can send messages back and forth. You just post a message to the web worker, and then you can have an event, an on-message asynchronous event that can fire if the web worker is sending data back to you. So the web worker could be calling Ajax web service, and maybe it's getting progress events because it's using the brand new XML HTTP level 2. And so maybe it could, as events are firing on that thread, maybe it'll send the UI thread a message, and maybe you'll update the UI thread. Hey, I'm 50% done, now I'm 75%. Things like that. So this is great stuff for web apps. Now, here's the tricky part. And I'm going to try to not burn up too much time here, because doing the demo for the web worker, as you might imagine, was actually going to use the interwebs here that I was previously connected to. So let's see if I can connect to this. Oh, of course not. All right, connected to. All right, let's see if we can get ShowNet working. Nope. I'm going to put it in airplane mode and go back. And we'll try ShowNet one more time. Or we could try trusty old Ethernet. When in doubt, right? Kind of flies in the face of a mobile demo, doesn't it? All right. Work. Let me show you the page here. So I have this web worker test harness. All right, I think we might be in luck. We'll see. If we get past the not responding part. All right, something came up. All right, let's see what happens here. Let's do this web worker demo. This is great stuff. We have this whole test drive for all these HTML5 features, this whole website, the IE test drive for IE10. You can go there to test out the different functionality, and that's where you go to get the code too. So all this is going to do is it's just going to launch a couple of JavaScript files. And I might need to refresh it. Oh, there it goes. Look at that. So this was showing you a demo of work being performed. The top one is doing the work on the UI thread, and the bottom one is doing it on a background thread, web worker. So you can clearly get the idea here that this is a good thing. When you need to get a lot of extra work done for the user, this is going to be your friend. And thank you, Ethernet. So much for the whole mobile thing, right? All right, WebSockets. Right now, when we do AJAX calls, it's request, response, HTTP. But we know that sockets are the very fastest way to communicate between point to point and send data super fast. And so WebSockets is this new HTML5 feature that lets you have this super fast connectivity, sending data back and forth between the server and browser. And you can see it can send all kinds of data types. And so you get out of the idea of polling using AJAX. Hey, is there something new for me? Hey, is there something new for me? And so there's this protocol, this negotiation that happens, like a handshake. When you start off, it is like an HTTP thing, and it basically is requesting of the server, hey, do you support WebSockets? Yes. If it does, then it'll elevate your communication to WebSockets, and then you're doing high-speed stuff. And so this is a feature of IIS 8, that we have in Windows Server 2012, and you just enable ASP.4.5 with the WCF activation enabled. Has anyone heard of SignalR before? Okay, awesome. I think SignalR is the coolest thing in the world. SignalR obviously has found a way to do this kind of stuff using all kinds of different Comet type, push, polling, whatever things. So my recommendation to you is, while you can write the native WebSocket code on the server side, I think it's easier just to use SignalR every time. SignalR, they did all the hard work on the server side, and you just use SignalR, and then the client JavaScript, how it makes it. And so SignalR will try to use WebSockets, but if it doesn't work, because not all browsers support it, not all servers support it, it'll fall back to one of the other mechanisms it knows that it can do push. Notice how I almost said push notifications. We think about native apps and how Windows Phone and Windows tablets have Microsoft push notification service. Apple has it for the iOS, for iPad. Android, Google has theirs. Think of SignalR as push notifications for the web. Why should the apps get all the fun? Why can't your website have push notifications too, just like apps, when something happens? So SignalR, I think, is an absolutely great way to do push notifications to the web. The other cool thing is they actually have an SDK with SignalR. You can put it in native apps too, all kinds of native apps, and it will do that. The other kind of weird thing I'll say about using SignalR for push notifications, so I do these executive briefings every week, multiple times a week. A lot of executives from all the biggest companies in the world, they fly to Microsoft, to Redmond, and they're there for 2 days, and we do briefings. Each product group kind of talks to them about the latest product, that version of Exchange, Windows, all the things. So I usually do most of the Windows Phone sessions. And needless to say, I was talking to a government agency that shall not be named, but they're kind of in the secret business. But maybe it's not so secret anymore if you've read the paper the last few weeks. Oops. Anyway, it was really interesting talking to them, because they were like, we can't do push notifications to apps for any platform because it's coming from a cloud. We can't have information ever leaving our secure lockdown network. It's got to begin and end inside our system. That's why they can't do cloud stuff, even though we'd love for them to use Azure. And so I was like scratching my head. I was like, wow, how can I give them push? SignalR. You can have your own internal secure push notification system using SignalR on your own servers in your own data center, and you don't have to worry about going outside if that's a problem. So I think it's a great product. It's great stuff. So anything that's real time, pushing information to the browser really fast as it's coming, or if you're doing multiplayer games, things like that. Lots of great scenarios. And look how simple it is to do the socket. So you have this strange looking WS, for that example. And that's how it starts off, and it does this negotiation. And then if it works out, there's this event for this ready state. If it works, then you can start sending data, text, binary, whatever you want. And then you have an event firing on your client in your JavaScript when new data is coming to you. And so you will find yourself maybe writing more server-side code to work with this or SignalR as you want to push information out to different clients. So this is how you can, I've seen lots of people do the simple chat demo to get started, but you could build some very sophisticated applications using this technology. So let's talk about hybrid apps. So sometimes you want your web app to get into an app store. Now, you remember the very first slide, the Gartner saying, 80% whatever is going to be web or hybrid apps in the future. A high percentage of apps in our store, in the Apple App Store, and Google Play are these hybrid apps. And so a hybrid app is basically, it's just a native app, one screen, one page, one whatever form with a browser control on it, and then the contents of the entire application is JavaScript, HTML, and CSS, and all your images. So because lots of software developers that want to build apps that target multiple platforms, but maybe they don't want to have to learn Objective-C for iPhone and Java for Android and our languages for our platforms and maybe Java for BlackBerry. And so doing a hybrid app is a great way to get to a lot of places all at once. So they don't have to know a lot of native code, because basically you just have a native shell around it. And then all the content, all the web pages. So the web pages either can be pulled from the server and use app cache to keep them offline, or the pages can be local from the beginning. And so in the local storage. And so you could have your whole website locally on your device, and your CSS and your JavaScript is all local. That's what a lot of people do, actually. And so it makes it very fast, and it loads up. And this is how you get to use your CSS and JavaScript and HTML skills. And you may have heard of PhoneGap, because there's a two-way communication going between the platform and the browser control. PhoneGap has wrapper interfaces, because a lot of times you're like, well, HTML5, it won't let me talk to the camera, or I can't talk to the accelerometer, or something else like that. And so how do I get native? Things like PhoneGap, but you actually don't even need PhoneGap. I mean, I can show you exactly how you do it yourself, but PhoneGap just makes it simpler for you. It kind of puts a JavaScript wrapper on native platform interfaces. Because what I mean by this is we have the ability to do two-way communication. So from the web page itself, the JavaScript on the web page, calling out. So in this case, this is the native code. Like this could be your C# or VB code in the native shell part of the app. It goes control, whatever the browser control is that you dropped onto the form, that control, and then invokes script, and then it calls the function, and then it passes arguments to it. So native can call asynchronously to your web page. And then, of course, you can go the other direction. Your JavaScript on the web page can call platform code using this window external notify and passing it in. So that's how it would call a C# function. So that's kind of, if you can imagine, that's how I'm going to get to the camera. And that's how I'm going to get to these other things, is through this two-way communication with the platform. All right. Let's fire up a quick demo. Let me launch an instance of Visual Studio here, and we'll just get after it and build one. Wow, look how many copies of IE we got there. All right. I'm going to close this. I'm just going to start fresh. So let's just launch a new copy of Visual Studio. And I'm just going to do new project. And this will be how you can see how to do it. So I'm in C#. I'm going to go to Windows Phone. And instead of doing a native app, you see right here, there's Windows Phone HTML5 app. So you click that. And it's going to put this together for you. And so if you just take a quick look at it, it's basically just one screen with this whole thing is a fully expanded browser control, a web view. Remember in the demos we've seen today where they were showing you web views, where it was showing the OpenGL stuff? That's what this is. That's exactly what this is. It's just a web view control inside there. And then you're going to get to have all your HTML and everything natively. So let's kind of just look around really quick here. If I click on the browser control, you can see some properties on the right. By default, geolocation and the ability to do JavaScript is turned off. So you'll check those checkboxes to enable that ability. If I look up here, up in the solution area, I can see different assets. Those are images. But here's the one with HTML. And so literally, the web page is right there, and it's local. So we're not pulling it from the internet. We're loading it locally. And here's the CSS. Notice it using that crazy thing I talked about called the viewport. So let's just run it. All right. So real simple. Using CSS, and you can modify the CSS yourself, it looks just like a Metro app, doesn't it? And if you go to my blog, robtiffany.com, I actually have, it might be a little out of date, there's probably some newer ones, but I created some boilerplate code that you can use to kind of the starter code for an HTML5 page, and some starter code for CSS that'll make your hybrid app, your web app like this, look like it puts the, it looks just like a Metro app. All the buttons are outlined right. I mean, it looks like you're using Metro controls. And so you can put that in there yourself. And then all it's doing there is, it's got a back and a forward and a home there. And so pretty simple. So let's take a look. Let's go back here on the web page. I'm not sure if I can do this or not. All right. Let's add some script. Let's add some stuff to this HTML page right now, because it's just a blank page. It doesn't do anything. And I want to illustrate an example there for you. So we'll put this down here under this div tag. I'm just going to paste this in. Doesn't matter how ugly it looks. And so what I'm pasting in there, as you can see, I'm creating just a text box. And then I'm creating a JavaScript function called callMe. And you can pass an argument, and then whatever that argument is, it's going to be rendered inside that text box. So now I've got to make this real on the native side. So where am I going here? I've got inside here my menu. All right, you saw that home menu? I'm just going to comment out that browser navigate on the home menu that would have taken you home, and I'm going to replace it with some other code here. So let's go up here, and this is that code I was talking about, browser, because that's the name of the browser control, and then I'm going to invoke script, and I'm going to call that callMe function, and I'm going to pass in the hello world. And so I'm going to put that in there, and let's build that solution. And let's run it and see if I copied and pasted it correctly. Okay, so here's the page now, and you can see that we got the text box. And now on the native side, where we put the native code, I'm going to click home, and it should call that function. And it worked! Yes! So anyway, that's the gist of it. So that's a simple example of the platform calling JavaScript to manipulate the browser. And then, of course, you can go the opposite direction. You can have buttons and things like that that'll call native functions on the platform. So you can probably see why a lot of people are interested in combining HTML5 with this native shell. You don't have to be skilled at C# and things like that, because it's, you'll barely writing any native code. 99% of what you're writing is just going to be a whole bunch of web pages and JavaScript and Ajax to call and get your data and things like that. And then you can use IndexedDB to take it offline. You only need to do this in the cases where there's some kind of functionality that's not provided to you natively by HTML5. So, our takeaway, we went through a whole bunch of web best practices. Most of them were around user experience, size of the pages, weight, things like that, making sure it looked right, making sure you were wasting space, making big fonts, making big things. So it's easy to touch and easy for people like me to see as I'm getting older, right? Because it doesn't seem as sexy as all the HTML5 stuff, but it's just as important to that good user experience. And then going through all those capabilities. And so you'll have the deck here, you literally just copy and paste that code off there. We have lots of great code on MSDN to go deeper into that. So when I talk to these chief information officers, because I'm trying to give you some real-world feedback from what I always hear, they are looking for the silver bullet. I hear these guys all the time. They're like, when are we going to have consolidation? I wish I didn't have so many platforms to target. This reminds me of the early days of the PC when I had, Radio Shack computers and IBM computers and Osborne computers, and they're all slightly different. He's like, and so they're very frustrated, They're not interested in who wins either. It's really interesting. A lot of these executives are very pragmatic. They just need to help their employees and their customers get stuff done. And so they look to HTML5. And I know you read the internet, and I know you probably all read when Mark Zuckerberg decided to take the Facebook app from being a hybrid app like I showed you and make it native, and everybody jumped all over it and said, oh, HTML5 sucks. Well, if you read further, he actually thinks it's the future of everything, and they just hadn't optimized it, and so native is better for them at the moment. I think the takeaway here is it's a journey. I think native's always going to be in the lead because the native platform functions are always going to be created first. But HTML5 is, and there's if you look online, there's already a deal out there for HTML 5.1. It's close behind, and it'll always be right behind there. And what did I say at the very, very beginning of the session? The words good enough. Sometimes good enough is good enough. I'll just make a blanket statement here about enterprise apps. I'm going to just say that 90% of all enterprise apps all do the same thing. They download data from somewhere, from a database, from a back-end system. You look at the data. It tells you what to do, where to go, whatever. You enter new data. You manipulate data. You might have some business rules, logic. And then you send the data back to the back-end system. That's it. That's pretty much every app. They all do that exact same thing. Yes, there's lots of differences in between, but that's pretty much what they all do. So you may think to yourself, well, if I'm just downloading data, okay, Ajax, and I'm saving it offline, okay, IndexedDB or web storage, and he showed me all these cool object stuff that I could put in there and object arrays, and I can take things offline, and I got the app cache and everything, and then I can capture data even when the network's gone, and then, and this cool thing too, with the app cache, there's an eventing system in there that actually can fire with network conditions change. So you can have intelligence about is the network there or not. And then when the network's there, then you can take that data you captured and do an Ajax call to send it back to your web service. Well, if you think of it that way, maybe a whole lot of your apps could be HTML5 apps. Maybe HTML5 is not quite as fast as native, but for the enterprise, if it's for your employees, if you're not trying to impress a bunch of consumers with their iPads, maybe it's good enough. I bet you at least 50% of what you need to do, you could switch to HTML5 right away, and it would be just fine. The other important thing, and this is great, is we have a browser war again, like we used to have in the 90s. A full-fledged browser war, and it's good for the consumer. I know we're freaking out at Microsoft because Chrome is doing awesome, and Firefox is doing awesome, and Safari is hanging in there. But this is good for the end users. That's who wins in all this. Because you know what? No doubt about it. When we had IE6 as the default standard for the web for all those years, that didn't help anybody. So now we have a browser war, and so what are we all doing? We're fighting to make our browsers more capable, make them faster, have these JIT compilers. So guess what? Every version of every browser, we're going to have to be fighting harder than ever before, especially against Chrome. They're doing great stuff over at Google. And so it's good for the user. So because of this browser war, your web apps are just going to get better and better, even without you changing code. When someone downloads the next version of the web browser, like IE11 or whatever, it's going to be faster. And so I think the browser war is just as important as HTML5 is, because it's going to help make these web apps great. One other thing I'll just say, if you've been in this business a long time, and you've watched large megatrends. So if we go back to the 90s and we go back to when the web really took off, what were the biggest trends that I saw that you probably all noticed is as soon as the web started getting even just the slightest bit mature, and I'm still talking the old HTML 3.2 days, and then we got to the 4.0, 4.01, in the late 90s, every company in the planet started changing all their Windows apps to web apps. You know how you've been at a lot of sessions and you have us talking about building apps for Windows and we need to get those apps back on Windows? You know what? The biggest culprit for apps not being on Windows isn't the iPhone. It's the web, and it always has been the web. The web has been the biggest upswing megatrend that changed everything in the last decade and a half. I'm not going to call the app phenomenon that's happened on the iPhone a blip, because it's clearly more than a blip. It's been a revolution. But the bigger thing that was already happening was the web. Maybe it paused for a little bit while everybody's going crazy building native apps. But like I said, that pendulum is starting to swing back as these web browsers get faster and more capable and more app-like. And so I expect to see a real web app resurgence. It also, some people don't want to be in the App Store. Some people don't want to give 30% of their money to Apple or Microsoft or Google. And so the web lets you do that for free. So anyway, lots of things to think about. I really appreciate you coming. I think we're almost done for sessions for this week. I think we've just got we got tomorrow morning's stuff. I recommend this if you're awake at 8:30, because obviously I'm not always awake at 8:30. Andy Wigley's doing a great session on building line of business apps with SQLite. It's some pretty neat stuff. So thank you so much for coming. I really appreciate it. Thanks.